In Chapter 5, Section 5, we are continuing with our state standard number 7, where we're adding, subtracting, multiplying, and dividing, and reducing and evaluating rational algebraic expressions. Now, we're not adding and subtracting today, so again, the blue portion is what we're not covering. We are starting to multiply and divide, and after we do that, we will need to reduce as well. So let's start out with our first example. We have x plus 2 over x minus 2 times the rational algebraic expression x squared minus 4 over x squared plus x minus 2. Now, I would like you to think of this. When we ask you to multiply rational algebraic expressions, say no. Just say no. What I would like you to do is think of it as one big rational algebraic expression that somebody started to factor and never finished. And think of what we learned in the previous lesson to reduce or simplify rational algebraic expressions. First, factor the numerators completely. Second, factor the denominators completely. Third, divide any factors that are the same in the numerator and denominator. These are not terms, but factors. And then fourth, in this case, let's leave your answer in factored form. So that's what our goal is going to be. As we do that, let's think of this as one big rational algebraic expression that somebody started to factor. So let's think of it as one big fraction. What I want to do is to continue to factor the numerator completely. So I have the difference of two perfect squares, x squared minus 4. That's going to factor into x minus 2 times x plus 2, the conjugates. And then I have x squared plus x minus 2. By FOIL backwards, that's x plus 2 times x minus 1. So we have everything factored in the numerator completely, everything factored in the denominator completely. Let's look for factors that are the same. There's an x plus 2 in the numerator and denominator, so those entire factors will divide out to 1. There's an x minus 2 in the numerator and denominator that are the same. Those will divide out to 1. And whatever is left, we're going to pick up the survivor, so to speak, for my answer. What's left is x plus 2 over x minus 1. Now, I find that students will do everything perfectly correct down to maybe this last step, and some of them will space out for a moment. So this is x plus 2. X is a term. This is x minus 1. X is a term. We cannot simplify it any further than what we have here. Right, this is called the division rule for fractions. We know that if a, b, c, d are real numbers and the denominators are not 0, when we have a fraction a over b divided by another rational expression c over d, that no one knows how to divide by a fraction. Instead, we multiply by the reciprocal d over c. So that's an important little reminder here. And we're going to apply that in this next example. We're starting out with x squared minus 1 over x plus 1, dividing by the rational expression x squared minus 2x plus 1 over x plus 1. First step is to not divide, but to use the division rule. And instead of division, let's turn it into multiplication by the reciprocal of this rational algebraic expression. Once we've done that, then let's follow my suggestions and not multiply, but think of it as one big happy fraction that somebody started to factor but didn't finish. And let's finish factoring it. X squared minus 1 is the difference of two perfect squares, so that factors into the conjugates x plus 1, x minus 1. X squared minus 2x plus 1 is a perfect square trinomial that factors into x minus 1 quantity squared, only for today I'm writing it as x minus 1 times x minus 1. Any factors in the numerator that are the same as the denominator divide out to 1. So x plus 1 in the numerator divided by x plus 1 in the denominator divide out to 1. X minus 1 in the numerator and denominator being the same divide out to 1. And what we're left with is our solution, x plus 1 over x minus 1. Cannot be reduced any further. You cannot reduce the x's because they are joined by plus or minuses, which makes them terms, not factors. All right, now this one, some of you start in shock to look at this and say, what is going on? We have what we call a complex fraction. We have a fraction where the numerator is a fraction and the denominator is a fraction. but it's just really division in disguise. So think of this as the great big division symbol. We have x cubed plus 8 over x squared minus 4 divided by x squared minus 2x plus 4 over x squared minus 4x plus 4. So it's just a division problem. So first step is to put it into something a little bit more recognizable. Second step is to use the division rule and don't divide, but turn that into multiplication by the reciprocal of the divisor. And then let's follow my suggestions of thinking of it as one big fraction that somebody started to factor and never finished. So let's factor the numerator completely, factor the denominator completely, and then we can simplify and reduce our fraction. X cubed plus 8 is the sum of two perfect cubes formula. For the binomial, we take the cube root of x, which is x, the cube root of 8, which is 2, the same sign. For the trinomial, we look at the binomial we just factored, take the first term and square it, multiply those two terms, plus 2x, and take its opposite, negative 2x. Take the last one, including its sign, and square it. Then the x squared minus 4x plus 4 is the perfect square trinomial formula, so that factors as x minus 2 quantity squared. For now, I'm writing them next to each other, x minus 2 times x minus 2. Yes, you can see that knowing how to factor from chapter 4 is very important here. Difference of two perfect squares factors as x plus 2, x minus 2 into those conjugates, and this will not factor. I can try by FOIL backwards, but the signs being minus and plus would factor if it factored into binomials with both subtraction. In that case, I'm looking for factors of 4 that add to 2. There are no factors of 4 that add to 2, so this trinomial cannot be factored. All right, now we want to look for factors that are the same in the numerator and denominator. So there's an x plus 2 in the numerator and an x plus 2 in the denominator. They will divide out to 1. There's the trinomial factors, x squared minus 2x plus 4 in the numerator, and conveniently 1 just like it in the denominator, which will divide out to 1. There's an x minus 2 and an x minus 2 in the numerator and denominator. That'll divide out to 1. And all we're left with in our numerator is x minus 2 and a 1 in our denominator, which we don't need to write. That's our look at simplifying or reducing rational algebraic expressions.